to Oracle Machine Learning Office Hours. I'm Mark Hornick, your host for today's session, Oracle Machine Learning and Football, Expected Goals. We welcome our guest speaker, Jeroen Kloosterman of Oracle. Jeroen is Technology Product Strategy Director for Oracle Analytics and Data Science with Oracle's small and medium business market in EMEA. He has over 20 years of experience in business development, product development, and sales training, and is an advocate for analytics and data science. And today, we'll learn about the concept of expected goals in football, also known as soccer for some of us, and how machine learning can be applied to understand team and player performance. As we go forward, please add your questions to the Q&A, and we'll address them at the end of the session. But before we begin, I'd like to get a sense of your objectives for today's session. Are you interested in how machine learning is applied in practice, or about cool machine learning use cases? Perhaps you follow anything related to football, or you have another objective in mind. And if so, please specify that in the chat. So we'll start the poll. We're seeing the majority here learn how machine learning is applied in practice. About half the folks just like learning about cool machine learning use cases. And we even have some who follow anything related to football. All right, so basically 90% are interested in learning how machine learning is applied in practice, with half learning about cool machine learning use cases, and about 10% that are just interested in football. Here's someone getting a certificate in data science, so trying to attend as many of these OML sessions as possible. All right, well, thank you for that, Jonathan. And with that, we'll end the poll. And I'll turn it over to Jeroen for Oracle Machine Learning and Football, Expected Goals.
Yeah, thank you very much, Mark, for the introduction. And of course, it's my pleasure to be here and tell you a little bit about the highest English football league, the Premier League. But before I want to start, I also want to ask you something in the audience. I'm sure you all have a favorite team. It may be in the Premier League, but I think it's mostly a US audience we have here. So maybe you have a team in the major league that you like. So put it into the Zoom chat. Let us know what is your favorite team. Maybe you can use analytics to make them perform better. Or maybe you have a national team that you like. Let us know and put it in the chat. And in the meantime, I'm going to start with this data story. Oracle is the official technology partner of the Premier League, and that means that we're having an impact on the game itself. So for example, now when a game is being broadcast on TV, there are all kinds of interesting metrics that help the fans or that help us to understand better what's going on and also have a more enjoyable experience. But I'd like to look at something different today, and I'd like to show you how teams or how clubs can use Oracle technology, and in particular, of course, the Oracle machine learning in the database, to really understand the data behind the game, behind the matches. And you're going to see how they can really understand performance and use the insight they get to make some important decisions. Now, I think the interesting thing is that the story that I'm going to tell you actually comes from a workshop that's also available to you or to the public. And that means that practically everything you're going to see today, you can also do yourself, because we've got the data and the exercises all available. And we're going to run that workshop on the 7th of July. Although I think, again, it's mostly a US audience, so I'm not sure how well the time fits you guys. But I'm going to share the details and hopefully some of you attend. Right, so with that said, we're going to talk about this team. Not sure how many of you are following the Premier League, but this is Manchester City. And if you follow this a little bit, you know that they won the Premier League just 3 weeks ago now. I think it got a little bit, it was a bit of a close finish. They were a little bit worried in the last match of the season that they might not make it, but they did. So of course they're ecstatic here and they're super happy. But the person I want to talk about here is their coach. This is Pep Guardiola. He's the brain behind the team. Of course, he's also happy, but he is already looking ahead, right? He wants to understand where his team is doing well, but also where it's not doing so well, where he could possibly improve. And what I want to show you today is how we can use Oracle machine learning to help Mr. Guardiola answer those questions and to see what he can do better or to get an edge over the competition and again win the title the next season. Okay, so we're going to look at expected goals, as Mark said, and it's also called XG. And that's a concept that's now been around in football for a few years, and it's quickly becoming, let's say, the metric that is used to understand football. Because if you think about football, if you just look at goals, normal goals, there are just a few of them in any game. Right? Maybe I think it's about 2.5 on average per game. So if you want to use goal to understand football, you have very little data to work with. So instead, what expected goals is about, this looks at the shots that are fired at the goal. Some, of course, result in a goal, others don't. But you have much more data. And with expected goals, we look at the quality, let's say the opportunity that each shot offers. And it turns out that with this metric, we can understand the game, the players, the teams much better and get some very valuable insight from that. So let's just take an example. Here we've got Mo Salah. I think he's one of the best players of the Premier League. He plays for Liverpool, and that was the team that finished second in the last season. You see him, he's about to take a shot, and on the bottom left, you see this 0.06. That's the XG value or the expected goals value. That means that there's this model that tells us that he is 6%, he has a 6% chance of making the shot and turning it into a goal. And that's taken into consideration all of the circumstances of the shot, like the distance, the angle there is to the goal, but also things like the position of the defensive players. So not very, very good odds, right, for Mo. Let's see what happens here. Beautiful goal by Mo. In fact, this was chosen by the fans to be the best goal of the whole season. So it was really done very well. So you may ask yourself, where does that number come from, that 0.06? Well, of course, we're talking about machine learning here. This comes from a machine learning model. So we're looking here at thousands of shots, multiple seasons of Premier League data that this machine learning model is trained on. And it looks at all these factors that are important of whether a shot becomes a goal. So it looks at the distance. Was it a kick or a header? What type of pass did the player receive just before he shot or made the shot? What was the playing situations? And so this model learns to recognize under what kind of circumstances typically a shot becomes a goal and when it doesn't. And of course, with what percentage, what factor chance there is to make that shot. And once you have that, you can apply it to one shot like we just did. But the interesting thing is if we take many shots actually and we apply that model to it, because that's where we get some really interesting insights. For example, looking at all of the shots of a particular player or looking at all the shots of even an entire team. And that's where Pep Guardiola can learn a few things. So we're going to see that. So what are we going to do? What I'm going to show you is how we build such an expected goals model ourselves using just the data that we got from the Premier League actually because of this partnership that we have. And once we have that machine learning model in the database, we're going to use it to look for those insights for the team and see what we could be improving to again win the championship next year. So let's go to building that expected goals model. And the first thing we need to do is just get a feeling for our data. So I'm in Analytics Cloud here, and we're just going to have a look at all of that shot data that was given to us by the Premier League. And yeah, this data set is called event, but it's about shots. So every record you see in this data set is one single shot. And what information do we have on these shots? Well, for example, this is a very important column here. Did this shot become a goal? And of course, most shots don't, right? What else do we have that's important? For example, the position that the player was when he took the shot. Now you can imagine that's pretty important for the chance of scoring a goal. because from that, we can derive things like the distance. How far was he away from the goal when he took the shot? Now, that seems to be important, but we're going to find out. And then there's all this kind of, let's say meta information or describing information that let us understand what circumstances there were. Like what body part was used? Was it a header or a kick? Was it the right foot or another body part? What kind of playing situation was it? Was it just normal play, or was it a counter situation or a corner situation or a free kick? And many more variables, right? We've got like 50 more variables in this data set. We're not going to look at all of them. But what is the challenge now? We want to build that machine learning model, that XD model. We first need to select what are the right comps for that model. And that's kind of the same as asking which ones of these variables here, of these columns, influence the chance of scoring a goal. Okay, so those are the ones that we want to select. We want to ignore the rest. Now, how can we find variables that have some kind of influence on the chance of scoring? We can do that with visualizations. So let me show you how we can do that. I prepared already a few things here. And the first thing I want to show you is just, let's say, like a helicopter view of multiple seasons of shot data. So this is thousands of shots, let's say, all added together. And what we see here is the score percentage of the score ratio. So this score ratio is simply the number of goals scored from a certain position divided by the number of shots taken from that same position. So for example, if you look here really close to the goal, you see 17 shots were fired and the score percentage is 1 here. So all of them became goals. That seems incredible, but that's if you get so close to the goal, you have a very, very high chance of scoring. And the challenge, of course, is to get so close to the goal in the first place. Normally, you don't get there. But then if you move further away from the goal, you see that this color quickly becomes kind of greenish. And here it's already at, you see that score percentage, 0.01. So it really drops quite quickly as you move away from the goal. So what we learned from this, distance appears to be very important for the chance of scoring, therefore important for a model. I don't think that's very surprising. But we also see something else. So pay attention here to this area next to the goal, on the goal line. You see there's not so many shots fired from here, and the shots that are taken hardly ever result in a goal, right? It's kind of this triangular area here, right? And on the other side, kind of the same. And that makes a lot of sense to me as a fan, because from here, it's very difficult. You don't have the right angle to the goal, right? The angle between the left and the right goalpost for the player from here is very, very small. So he can hardly see the goal mouth. That will make it difficult to score a goal. Again, that's not surprising, but in my data set, I don't have that angle yet. So what I learn, I want to have that angle, I will have to extract it, okay? So we're gonna see that in just a little while, how we do that. So angle is important, distance is important. We also see some weird outliers here, some anomalies. What's going on there? For example, this one here that's even behind the middle line. How can that happen? It seems to be some kind of great spot to score a goal from. Well, the point here is that, look at that, event count is 1. That means that only 1 shot was taken from that in several seasons of data, and that just happened to become a goal. So it's logical you get the score percentage of 1. In fact, I've got a video of this particular shot. So let's have a look at that. And this is a shot taken by Rooney. And you see he's indeed here behind the middle line. So let's see what happened. Yeah, small mistake by the goalkeeper, beautiful finish by this player, by Rooney. But what does this mean for us, right? We're trying to build this model. Now, do we learn from this that this particular location is like some kind of sweet magic spot where we should try to take a shot from because we have a high chance of scoring? No, probably not, right? this is just because we don't have so much data there. So we have to keep using our common sense and also not just rely purely on this kind of visualization. Okay, so we want to select the distance. We want to select the angle. We'll have to extract that later. Those are not so surprising factors, I think. So how about things that are less obvious? For example, I was wondering what's the influence of whether a shot comes from a corner or doesn't come from a corner on the chance of scoring. So let me explain this other chart for you to show that relationship. Here we're looking at several seasons of data, and we're looking at all the shots that were taken over here on the horizontal axis from different distances from the goal. And by the way, here, these outliers, these are just those same outliers that we saw before, right? So you can ignore those peaks. And here on the vertical axis, you see the chance of scoring, right? Between 0 and 1. And or the score percentage, really, I should say. So I'd like you to take notice of the difference between the yellow and the black line, because the yellow, those are all the shots that were taken from corner situations. And the black one on are the non-corner situations. So notice how the corners like consistently lead to a lower amount of goals. So that tells me this corner variable causes a clear pattern, right? It affects the chance of scoring very significantly. And that means that it's a good candidate for our model, because our model is supposed to predict the chance of scoring. So this is valuable information. So this is how we go about selecting those variables, right? So you definitely want to include this variable from corner. Right, so let's do one more so you really understand this concept. So here we're looking at counter situations. So if you're into football, you know that a counter is when the opponent suddenly takes possession of the ball and then runs quickly to the other side, trying to make a goal before everybody's in place, right? When there's kind of chaos. And here we also see a clear pattern. So here in yellow, we see the corners, and in black are the counters, and in black, the non-counters. And you see that counters lead to a higher chance of scoring, right? It's like practically for all distances, it's higher. Well, apart from maybe here around 20 meters. But again, this is causing a clear influence on the chance of scoring. So definitely we want to select this variable when we go build this model, right? So this is the process, how we can use visualization to select variables to build our model on. So let's say we've done that and we are ready for the machine learning building phase. So we've selected a number of variables. So we're going to get to that step. So I'm going to go to my machine learning here. And before we're going to build our model on the data that we selected, remember that it was this one variable that we don't have that, but we want to extract. And that is that angle, right? So we have the position of the player when he took the shot, but we don't have the angle yet. So here we're first going to do a bit of feature engineering, as we call it, some data preparation. And here we can use all of the Oracle database functions. And in fact, there are some trigonometry functions also in the Oracle database. And you see here it's using the tangent to calculate that angle, right? From the position of the player, which is y rel m here and x rel m, it calculates that angle that exists between the two goalposts. So it basically takes the angle towards the left goalpost and the right one, and it subtracts them. And that's the result that we get, right? So I think it's really great because we can do that here in the database in the same notebook where we do the machine learning without having to bring the data out or into some other kind of platform. And it's a very rich environment, right? We've got all of those functions, even trigonometry functions in the database, with who would expect that, right? So it's a very rich functionality. Okay, so let's say we've done that. Then we're going to get to the actual machine learning, right? We're ready to do that. But before we do it, I need to just talk to you about the kind of model we're going to build, because that's maybe not as straightforward as you might think. So anytime we build a machine learning model, and if you've done this a couple of times with Oracle Machine Learning, you know that we try to fit a function to data that we have, right? And once we have that function, we can use it to make predictions. So let's just plot some data that we have. And let's say we have extracted that angle. And we're just going to plot those shots that we have, the existing data, which ones became a goal and which one didn't. So here we see the angle from 0 to 180. This is very close to the goal. So it's like wide open. And this is when you're far away or when you're to the side of the goal. Okay. So you see, when you have this very low angle, you have less goals. And when you have this very high angle, you start to get more goals. But of course, this is a discrete variable, right? You either make the goal or you don't. There's nothing in between. But if you think about our end goal, we are not so interested in this 1 or 0. We want to have the chance of scoring a goal. We want a continuous number, right? So when you think about that, you think, hey, that's regression. For example, we could use linear regression because it's a continuous number, right? So let's try that out, that idea. And I'm just going to plot a line here. This could be, for example, how linear regression fits a line here, fits a function. And you see, it's not a particularly good fit because most of the points here are very far away from this line. And also you get this weird phenomenon that once this function is there, and imagine here we would ask to this model, what is the chance of scoring a goal for an angle of 0, right? Well, then it would give you something like minus 0.25, I think. Or if you here go to 180 degrees and you ask, what is the chance of scoring a goal from there? You would get 1.3 or 130%. And that, of course, doesn't make sense, right? You can't have a chance of over 100%, and you can't have a chance of less than 0%. So this all doesn't really make sense. And in fact, what we need to do is use a thing called logistic regression. Okay, so what logistic regression is this doesn't plot such a straight line, but it plots a curve. And the angle of attack here of this curve that can have different shapes, but it's always a curve, steeper or less steep. And it always has a value, or it's always between 0 and 1. So you can never have these weird situations, right, of a chance of lower than a 0 or higher than 1. So where is this used? This logistic regression is in fact used in classification. Okay, so, and if you think about classification, that always returns discrete values, right? So the example here would be, if we wanted a model that tells us, will this shot result in a goal, yes or no? And this model will tell us yes or no, and nothing in between, right? That's classification, right? But of course, that's not what we want. We want the percentage of chance that a goal is scored. So keep that idea in mind, right? Because we need to use a classifier for this, but we don't want to use these discrete values, right? We want the percentage. So now we'll go back to the notebook and it will all start to make sense. So first of all, what are we doing? We're selecting all of those variables that we said those will probably influence the chance of scoring, right? That we found in the previous process. So we're doing that here. Yeah. We're selecting, or we're creating a table for that to train the model. Then we're setting up a very small, let's say, hyperparameter table for the model. And all that goes into this is, hey, I want to use this particular kind of algorithm, the generalized linear model. And now we're saying we want to create a classifier, right? Classification, it says here. We're going to call it the XG model, okay? And the trick, why I was all telling you this earlier, is here. So once we have this model, it's been done right after this. Once we have it, we make our predictions. Now, of course, we can ask our classifier, will this shot become a goal? And that we do with this thing here, prediction, right? Tell me, will this become a goal, a 1 or a 0, or a yes or a no? That's what will come out of this. But we can also ask for the prediction probability. And that will ask our classifier actually for that, the value of the function that is inside of it. So this will tell us the percentage of the chance that it will become a goal. I hope that makes sense. That is, of course, our expected goals value. That is our XG value. Okay, so that's what we're now storing in our event table in our shots data. So with this statement, we effectively enrich all of our shots, and all of our shots of all these seasons now have an XG value, right? What was the chance of scoring that shot? So that's done, okay? And now we can go back because now we can actually start to use this and look for some insights. So let's do that. And we go back to our analytics. Okay, and we're going to look at just one particular match. So I'm just opening that here. And this is a match between Liverpool and Manchester City. And it ended in, I have to zoom out a little bit here, I think. Yeah, in 2-2. You see that, yes? Now, every shot we can now display on a helicopter view, and we've done that here. That's not so special. But what is special is that we can now show the XG value for each of these shots. And we do that now with the size of the circle. So the bigger the size, the higher the XG, the higher the chance of scoring that shot was. So let's take just one example. For example, I'm clicking on this one here. You see this has an XG of 0.08. You see that? And if we scroll down, we can also see who this was. This was a shot by Kevin De Bruyne. So 0.08, 8%, still not a very high chance of scoring. But let's see what happened here. Yes, a beautiful shot also by Kevin De Bruyne. Of course, I've picked the nice moments. You can imagine that. But he scores from pretty far away, and that's kind of his trademark. Okay, so, and we're going to see that later, actually, when we look a bit closer at this player. Okay, so you think, right, so we can say what is the XG value of this shot, but how useful is this to me? Because you're not going to use this to predict, will this shot become a goal? Because by the time you can see that's happening in the game, you're already too late, right? So you can't use this to make a bet on a game, right? That's not what this metric is for. This metric is more for looking back on a game or looking back on an entire season to understand performance. And as I mentioned earlier, it becomes interesting when we look at many shots. So for example, this value here on the top left, that's the cumulative value of all of the XG for Liverpool. So taking all of the shots that they fired, which were 6, if I see quickly here, the combined value of that was only 0.43. So realistically, they were expected to score 0.43 goals. Of course, that doesn't exist, but that's not a particularly high number, which tells me they've been doing very well with the few opportunities that they had because they scored 2 goals, right? And same can be said for Manchester City because their XG is almost 1. So realistically, from all of the opportunities, the shots that they took, they would have been expected to score 1 goal, but they scored 2. So both teams did very well from the few opportunities that they had. So this starts to become more interesting already, right? But now let's come back to our coach, Pep Guardiola. How can he really use this and to get some valuable insights? Okay, so he's first going to analyze the offensive side of his team. He's going to look at some of the other strikers and the midfielders, etc., and see how they perform. So here, we're taking all the results again of that machine learning model in the database, and we're applying it to one particular player. And this is the player Sterling. Okay, he has shot 54 non-penalty shots in the 2021-22 season. He scored 11 goals from that. Oh, those are normal stats, right? Nothing special. Here it becomes more special because we can see now that the combined XG value of all of his shots is 9.75. So he was realistically expected to score about 10 goals from the opportunities that he had. So he overperformed a bit. He's kind of on par. So that's a good result, because what is the real, let's say, the positive thing here about Sterling? The fact that he creates that XG, those opportunities in the first place, right? So it's not just about the difference, for example, between opportunity and actual goals. It's also just about creating the opportunities. And he's able to do that because you see he's able to get here in the zone. He gets really close to the goal and is able to make those shots from there, right? So that's definitely a skill. Now let's take a very different player, Kevin De Bruyne. We just saw him before on this one shot. He shot 78 times in the last season, of which he scored 15 goals. And now comes the really interesting thing. According to our XG model and looking at all of the shots that he took, he was expected to only score 5.93 goals from that. So remember, guys, this XG value, that's kind of a metric of the average player in the Premier League, right? It doesn't say anything about Kevin in this case in particular. It's just asking, what would the average player have done with these opportunities? So the average player would have been expected to score only 6 goals, but he overperformed here with 9 goals, right? So that's really massive over performance. And you see that he generally scores from difficult situations. So for example, here you see all these shots that were taken from very far away, yet he manages to convert them into goals, right? So imagine our coach, he can do this for all of his players, of course, and he finds out that on the offensive side, things are looking really, really good. And let's just say that he doesn't really find a point of improvement here, okay? Now, what we can do now, we can look also at the defensive side of the team, right? Can we improve something there? In fact, we want to look at the goalkeeping now. And before we do that, I just want to share one more thing with you, because our XG model as we had for goalkeeping, it isn't perfect yet. Because if you think about goalkeeping, the XG model we had so far only looks at all the factors that are taken into account just until before the moment that the ball leaves the foot of the player, right, of the shooter. It doesn't take into account yet where that ball is headed. And that's of course not really fair, because to really judge how difficult the shot is for the goalkeeping, you also have to keep in mind at what position in the goal was that shot fired. Was it fired at the top corner? Then it's probably a lot more difficult than if it was fired right straight through the middle, right? So what we're doing now is we take that XG model, but we change it a little bit. We retrain it, and we also include the projected position in the goal. Those are just 2 coordinates, right? Like an XY coordinate. And we let the model find out like which shot is more difficult, right? And we get from this a model that basically tells us how likely is it that the average goalkeeper of the Premier League lets a certain shot become a goal, right? That's the result of this one. So I'm not going to show this. You've seen the notebook now. You can imagine it's the same notebook with just extra parameters in there. So now we go back to our analytics, and I've applied that XG on target model, as it's called, to all of the shots that were fired against Manchester City. So the shots against, right, from their opponents. And we see that they had 141 shots against them, which we can now visualize. And with the size of the circle here, we can now show that XG on target value, as it's called. So for example, this basically means an XG on target of 0.49, that the average goalkeeper would have let this particular shot become a goal in about 1 out of 2 cases, right? That's what our model tells us. So in fact, let's take a look at this shot. Yeah, so very good block by Ederson, the goalkeeper. And now again, that's interesting for an individual shot, but the really interesting insight comes if we look at a higher level. So from those 141 shots, 25 became goals. Now, if you look at that as Pep Guardiola, you would say, hey, that's really low. It's the lowest goals against in all of the teams in the competition. So at first sight, it seems like there's no problem there at all, right? And the goalkeeping is in perfect shape. But now the really interesting thing comes. If we ask our XG on target model, how's the way to formulate this? So how many goals would have been scored given all of the shots that were fired and the difficulty of those shots? How many shots would the average goalkeeper have let become goals? Yeah, I hope I've expressed it well. Then this model tells us we would have expected only 21 or 22 goals from all of those shots, right? Given their difficulty and all these things. And we actually let 25 of those shots become goals. So we've underperformed here with 3 goals. And that's the big insight for this coach. So he's learned with Oracle Machine Learning that although at first sight, everything looks good on the goalkeeping side, there is actually space for improvement, okay? And that's very valuable, of course, because he knows what to look at. Just to illustrate it a little bit more, let's take another team here that was doing very well on the goalkeeping side. So this is Wolverhampton Wanderers. They ended much lower in the competition. So not one of the top performers there, but in terms of goalkeeping, they are very good because they had 300 shots fired against their goal from the opponent. 33 of those became goals, but according to our model, we would have expected 48 of those shots to become goals. So that's much better than you would have expected. With 15 goals were stopped, more than you would have expected. So this just shows what big of an impact like improved goalkeeping can have on the situation. So that's the big insight for our goalkeeping and for Manchester City. So this is just one of the cases where machine learning can help in football and in sports in general. Now, before we go to the questions and before I share the workshop details with you, there's one more thing I wanted to show you. It has nothing to do with Manchester City, but I was interested to find out what was the most improbable shot in the season or in the last season. And in other words, what was the shot with the lowest XG or expected goals value? And that's a shot here by Visa. You see him here on the bottom right in yellow. This shot has an XG of only 0.015, so 1.5% chance that the average player would have scored this goal. So let's see what happened here. Yeah, incredible shot, isn't it? I'm still wondering, did he try to just give the ball to one of his teammates, or did he actually try to score that shot? In any case, it's incredible and amazing, I think, how he did this. So I think we can take some questions now, and I will also post this link in the chat with you. This is the link to that workshop that I was talking about on the 7th of July. It was planned for EMEA region, really. So I'm not sure in terms of the audience if the timing suits you, because I think most of you based in the US. But I want to share it with you anyway, and you're more than welcome to join and experience everything that we've just done for yourself. So yeah, Mark, I'm not sure if you've been watching. Great. If we have any questions or comments.
Oh, absolutely. Definitely questions. So thanks for that exciting talk, Jeroen. That was really fantastic. Some of the questions that came in were around perhaps supplemental data that you might use for this. So some of the other things that were mentioned is, what about the difficulty to get to a high scoring location? Or does team skill play a part in this, or their home or away? Did you look at other types of variables?
Yeah, those are very interesting ones. I looked at a couple more. Home and away I didn't do. I did look, for example, at the time in the match. Like, is the chance of scoring the goal higher if you just a little bit further progressed in the match. And yeah, I couldn't find that relationship, let's just say that. So in the visualization, I thought I found a relationship there, but if I put it in the model, it didn't really become any better or any more accurate. But yeah, it's, the machine learning, it's an ever improving process. So those data points are definitely worth investigating, I think. Yeah.
Cool. So I guess along those same lines then, in terms of identifying which variables are the most important, or identifying the ranking of those for predictive value, you took a visual approach to that. Did you also consider looking at maybe an algorithmic approach and even some of the algorithms that we have in OML to support that effort?
Yeah, so there's definitely facilities in OML to help with that, right? To rank and to see the influence of the different variables. You can use that and then also try out to see if you can confirm that. I like to use the visual approach just to have this first selection, right, of variables, and then later also take a numerical approach and comparing them to see if you maybe have better or higher success if you remove one of them, for example.
Yeah. I really like the visual approach, and it gives you some intuition as to what's factoring in there. So it certainly is nice to see. Another comment here on just additional factors: are you factoring in the velocity of the ball for the shot or the location distance of the nearest defender? Is that a type of information even available?
Yeah, that's a very good point. So we have this. Because of the partnership with the Premier League, we got this data set that's very, very detailed. I think it's already quite incredible, everything that's in there. I'm not sure if that contains the velocity of the shot. I have certainly not included it, but to be honest, there's too much to see to understand everything in the data set in the experiment that I did. It would definitely be a factor. So for example, this Kevin De Bruyne, he's known to shoot very with very high speed. And I can imagine that would have a big influence on the chance of scoring.
And when you were comparing the two players, Arun notes that one player took 54 shots and the other took 78 shots, and it looks like one is more influenced by angle while the other is more influenced by the distance. Is that something that you've looked at as well?
Yeah. So the interesting thing is, in this particular model, I actually went to only include angle. And the reason I did that is that, that's a little bit complicated to explain, but the angle actually also contains, in a way, the distance information. Because if you look at the angle, of course, if you go to the sides of the goal, the angle gets very small, right? You can hardly see the goal mouth. But now imagine a situation that you're right in front of the goal at 5 meters from the goal. Then you would have quite a wide angle, right? But if you move further away from the goal, that angle also becomes smaller, right? Even if you're straight in front of in a straight line to the goal. So the interesting thing is that the angle describes in just one number the difficulty of scoring a goal, not just because you go to the sides, but also if you get further away. And so that's why I first went with angle alone, but it's certainly interesting, I think, also to include distance. So to try that out. And I mean, I guess that's the message to everybody. Try it out yourself and start with this data set and then add data or remove it and see if you can improve the accuracy.
Very interesting approach. One last question we have, and I think you've already addressed it, but I'll just state it one last time, is where could we find the files of this use case, or could we access it on the cloud?
Yeah, so this is not yet available. It will be from the 7th of July when we run this workshop. So yeah, if you want, let's say, the earliest access, try to join us on this date. And after this date, we'll also have it available on Oracle Live Labs. So I'm not sure if we can share a link to Live Labs in general, and then people can perform a search on that.
And we can also add that link in the office hours webpage as well. So
that would be great.
Sure that's available for everyone.
Awesome.
All right. Are there any last questions then? It seems like we've covered all of them so far. And so with that, Jeroen, I thank you very much for this presentation. And everyone else, we'll see you at the next event.
Thank you, guys.